Part of the slope field given by dy dx is x minus 1 over 2y is shown below. Calculate and draw the slope field at the point 0.5, negative 1, and they've given us that point here. So we have that x is 0.5. So we've got 0.5, take away 1. And that y is negative 1. So that would be negative 2. So we've got negative 0.5 over negative 2, which gives us 0.25. So that's going to be a fairly shallow gradient. 0.25, of course, is 1/4. So that means for every 4 units we go across, we go 1 unit up. And we should try to do this with reasonable accuracy. So I'm going to go 1, 2, 3, 4 units across, which would be to here. And 1 unit up would be there. So I want to draw in that sort of direction. And so what I'm going to do is just draw a bit of tangent there, and I'll go back the other way as well and draw something like that. Now we may want to shorten that a bit once we've got it, but I would draw it long enough to show that we're reasonably accurate there. Now we want to determine the equation of the solution curve that contains the point 0, 0.5. So I'm going to work in this area up here. dy dx is equal to x minus 1 over 2y. We can separate and integrate. So the integral of 2y dy is equal to the integral of x minus 1 dx. So that gives me that y squared is x squared over 2, take away x plus some constant. Now if we're using 0.5, that means that 0.25 is equal to c. So we have y squared is x squared over 2 minus x plus 1/4. I want to draw the solution curve that contains the point 0, 0.5, which is this point here. The y squared here indicates symmetry around the x-axis, and therefore it must go through this point here. Now, when I go to the left of the y-axis, I'm reasonably confident about just trying to follow the line of the tangent field and getting something that goes like this. Try to get it looking reasonably symmetric. And then we've got to get this. I'd like to try and get that x-intercept fairly accurate. So what I've done is I've solved x squared over 2, take away x plus 1/4 equals 0. We know that the x-axis is y equals 0. And I've got two solutions. The 1.7 solution clearly doesn't follow the tangent field. And it's all to do with the fact that this is a hyperbola. And there's actually another bit over here, which they're not interested in you drawing. But this one here is at 0.29. So that's a bit more than 1/4. So that's about there. So I'm just going to follow that round to there, just to get that bit accurate, just in case out of the 2 marks for this part, they want reasonable accuracy at that point.